Previously on the Advent of Cyber. The elves in Santa's Security Operations Center are hard at work.
I've just clicked on something and now my workstation is behaving in all kind of weird ways. Please can you take a look?
Running down to the workshop floor, you see a command prompt running some code. Uh-oh, this ain't good. And we have our results back in, and you can see that NT Major version, which is 10. So I'm just looking for one that stands out. It's right there, it's mysterygift.ex. If we scroll up, we've got PID, PPID, so we know it's the first one, which should be 2040. So go progress. 2, 3, 4, 5, 6, 7, 8. Hello world and welcome to Hacks. We are back with the TryHackMe Advent of Cyber 2022 and we are now on day 12, malware analysis. Forensic McBlue to the rescue! As with the memory forensics, I have very little experience with malware analysis in my short time in cybersecurity, so this room is going to be completely new to me. All the tools and techniques in here I will be learning for the first time. I may have dabbled a bit with it on Hack the Box or some other labs, but never really gotten too into it, so I'm really looking forward to this one and what it can teach me. The story. The malicious document attached to the phishing email was confirmed to have been executed. Damn it, Dave. Aside from the fact that rogue connections were observed, we know little about what it does. Our in-house expert, Forensic McBlue, confirmed that the malicious document spawned another suspicious binary. Pivoting from that, he dumped it from memory for this task to be further analysed via malware analysis. And the learning objectives of this room are to learn the fundamentals of analysing malware samples without relying on automated sandbox scanners, and to learn and understand typical malware behaviour and its importance in the instant investigation pipeline. Key malware behaviors. So what is malware? Malware is malicious software. It has many different intentions. It depends on the author of the malware. It could be to spread through the network, to develop a botnet, to mine crypto, or just to steal sensitive information. And there are certain behaviors that can allow us to identify malware. The first one is network connections. Malware will tend to communicate back to a C2 or a command and control center to download further instructions or to download the rest of the payload. Registry key modifications. This is a way that malware can get persistence on a system, so if there were disruptions like the system shutting down, they could modify registry keys so that it can be automatically executed when a user logs in. File manipulations. Malware tends to download or create new files needed for successful execution, so it would download files from, again, a C2 in order to complete its task, or it would modify existing data on the system, so this could be in the form of encrypting it as a form of ransomware to then target assets so that you can get money off of the victim. The dangers of malware analysis. Obviously, if you're going to be dealing with malicious documents, there is a potential for it to infect your computer. That's why most malware analysis is done in a sandbox, likely disconnected from the network so that the malware can't spread through the network to other machines or even infect your local machine. There are two types of malware analysis, static analysis and dynamic analysis. Static analysis will be looking at the file, trying to get things like strings out of the file to see what files it's accessing and to try and understand what the malware is doing, but without executing it. Needless to say, this approach can be problematic as you do not actually get to execute the application, so you may not get to see what it does. Dynamic analysis focuses on understanding the malware by actually executing it, so you can check the processes and check the network connections while it's executing to see what it's actually doing. So we can actually profile malicious executables through static analysis, and we have a lab. If you spin up the box at the top of the page and then you can jump into split view, we can actually get hold of a malware sample, and using a program called Detect It Easy we can run through it and look at what sort of information we can find from it. All I'm going to do is I'm going to jump into the malware sample on the desktop. I'm going to right click it and I'm going to choose Detect Easy. The author of the room explains that upon opening the program with Detect It Easy, we immediately understand the architecture of the application and the packer that's used. So I'm going to assume that the console 64 means that it's 64-bit and the packer used is UPX 3.9 NRV best. With that information we should be able to come down and answer the first question. So as I suspect it's a 64-bit, we should just be able to type in 64-bit and click submit. Then what packet is used in the malware sample? Format lowercase. We're looking for 3 letters. I assume that's going to be either UPX or NRV. UPX. So we've identified the packer, but what is packing? Well, packing malware is a common technique used by malware developers to compress, obfuscate, or encrypt the binary. With this, the contents such as significant strings and headers will not be immediately available to static analysis tools. In order to demonstrate this, we can run strings against the binary, and you can see there's a lot of gibberish. You've got this program cannot be run in DOS mode, but scrolling down the list, there isn't much that makes sense as far as I can see. But this is essentially what a packer does, is it will obfuscate the code so that it's broken down, a bit like what we did in the CyberChef email analysis, where we had to decode and drop bytes to decode the base 64 before we could see what the actual program is, and then we had to run regex to remove all the square brackets. As you can see, it's a lot of gibberish. Anyone looking at this probably isn't going to get a good idea of what's going on with the program because it doesn't make sense. So to confirm that the binary is packed, we can run a program called Kappa. So if we cd into the malware analysis directory, so then we can run Kappa on mystery gift. You see there's performing an analysis against it. This sample appears to be packed. Packed samples have often been obfuscated to hide their logic. Kappa cannot handle obfuscation well. This means the results may be misleading or complete. If possible, you should try to unpack this input file before analyzing it with Kappa. So what we can do is we can help Kappa out by unpacking the malware sample and then rerunning it through Kappa. And then mysterious gift. And then we should get a message pop up to say that we have now unpacked one file. So if you list out the contents of your directory, you may see that you have a mysterious gift.viv file. That's going to be left over from the previous Kappa results. I don't have one because the virtual machine disconnected and I had to respawn it, but you need to delete that. So you can just do del for delete and then mystery gift and then .viv, and then once you run that, you'll be ready to run Kappa again, which you can do by just doing Kappa mysterious gift. And as you can see, the information we get back from it now is a lot more informative, and we actually have references to different frameworks like MITRE ATT&CK that tell us about the actual binary. And one bit of information that we need from the output, I mean, it's good to go through and check all this and read all of it anyway, but we need the compiler, which is nim. And then if we jump to our questions and answers section, we can scroll down and see that one of the questions is, what is the compiler used to build the malware sample? Answer it in lowercase, and we can just type nim. The next question asks, how many MITRE ATT&CK techniques have been discovered attributed to the discovery tactic? So if we look at the output of this again, we can see we have discovery there. We've got T1083, which is file and directory discovery, and T1082, which is system information discovery. So I believe the answer is just going to be 2. Okay, so now it's time for a deep dive dynamic analysis of the binary. We're going to be running the binary and monitoring it using process monitor and checking to see what type of nefarious actions it's up to. But first of all, we're just going to run process monitor, and then we're going to change these filters to process name is, and then we want to put in mystery gift exe, and then we're going to click OK. And the next thing we need to do before we can execute the program is we need to give it the .exe extension. So we're just going to do move mystery gift to mystery gift.exe. And now if we go into the malware sample file, we should see it there as an executable. Okay, let's try that again, shall we? So first of all, we're going to launch procmon, and then we're going to say process name is mystery gift.exe, but we're going to change this to contains instead of is. Then we're going to click add, we're going to click apply, we're going to click OK, and we're just going to leave that in the background. Then we're going to open our terminal, and then we're going to cd to desktop malware, and then we're going to move mystery gift to mysterygift.exe, and this allows us to arm our payload provided we actually use mv and not mc. So when we go into the directory containing the payload, it's now an executable rather than just an ordinary file, and now we can run it. Then that will launch, but process monitor will not show anything, and I was looking at this for a while getting stumped thinking where's all the data? You have to click on things like the registry filters or the file filters, but as you can see the amount of data that we get is quite overwhelming, so we're going to need to right click some of these and exclude them from the results. So the first thing we're going to do is right click reg open key and click exclude reg open key, and the next we want to do is right click reg query value and exclude that one as well. Then we want to get rid of reg query key wherever that one may be, so we're going to grab this and exclude reg query key. And the last one we want is reg close key, so we're going to grab that and click exclude reg close key, which should leave us, if we get rid of the profiling events, it should leave us with a few entries. Now we should be able to see there's only one value that has both the reg create key and reg set values set, and I believe this is the answer to the next question: what is the registry key abused by the malware? So we should just be able to go hkcu /hk software Microsoft Windows current version run. But yeah, we have the correct answer, and then it asks what is the value written on the registry key based on the previous question. So I just lost the box again, but it's back up and running. Ugh. It's a nightmare today. So I think the actual file they're looking for is C users administrator app data roaming Microsoft Windows start menu programs startup wishes.bat. Answer is correct. I can't believe I was able to type that out all in one go. The next question asks, what are the names of the two files created by the malware under C users administrator directory? And I lost the box again, but we're back, and we can do this by doing exactly the same thing that we did the registry. We can right click on create file and click exclude create file, right click on file mapping and click exclude file mapping until we go through all of these. We're left with only a few results back which will tell us what files we need to look for. So we need to exclude query name information, and we're going to exclude close file, and we're going to exclude read file. Then if you come down here and expand these paths a little bit, you'll see that there's only two files that we need to worry about. You've got test.jpg and wishes.bat, and those should be your answers there: test.jpg and wishes.bat. And the next question asks, what are the two domains where the malware has initiated network connections from? Domain 1, domain 2. Okay, so explains again how we do this, but this time we don't actually need to format anything. It's very clear that there's only two domain names. It's bestfestivalcompany.thm and virustotal.com. It's the only connections it makes outwards. But this is really awesome that you can see where a binary is making calls to externally. And the final challenge asks us to go back to strings inside the malware sample. What is the complete URL used to download the file hosted in the first domain accessed by the malware? So all I'm going to do for this is I'm going to right click the binary and I'm going to choose open with detect again, or detect it easy, and then I'm going to run strings on that and hopefully find a way to filter it via the domain name that we found for the best festival. So if we run strings against it, we should now be able to put in something like http if it wants to type. Try that again, shall we? Let's try that again, shall we? http :/ and there you have the answer: http bestfestivalcompany.thm favicon.ico. So they hid the malware in favicon.ico. I think that's what I'm getting from this anyway. So http bestfestivalcompany.thm favicon.ico. We have finally completed this room. Ugh. All I can say is I'm relieved, to be honest. I didn't really enjoy it that much, mainly because of the just crazy amount of connectivity issues I've had with this one. It seems I couldn't do a single task without having to reboot the box because it disconnected. There we go again, another network connection issue. I'm not sure what's going on their side. I've rebooted my router and everything this side, so it's not a me issue, it's a them issue. Hopefully they get it fixed. But yeah, it made this less than enjoyable. The content of the room is great, and I will like to go through it all again to get a better understanding of it all, but right now it just seems that TryHackMe is unusable. Somebody is probably playing silly buggers on their network for their own amusement, or they've got a technical issue, I don't know. Either way, that's all I've got for you today, and yeah, I hope you liked it. I'm not happy with this video and how it turned out, but you know, live to fight another day. We'll make a better video tomorrow. Kind regards.